Power relations in AC circuits. Instantaneous power in AC circuit. In a passive AC circuit, let the instantaneous voltage be V equals to Vm sin omega t, while the current is given by I equals to Im sin omega t minus phi, where phi being the phase difference between the voltage and the current at any instant. Phase difference, it's negative for voltage leads, positive for voltage lags, and phi equals to 0 when V and I in phase. Now, the instantaneous power P is given by V I, that equals to Vm Im sin omega t multiplied by sin omega t minus phi, multiplied with 2 and divided with 2. Then Vm Im sin omega t minus phi. Vm Im by 2 sin omega t minus phi. Then you are going to get P equals to Vm Im by 2 cos of omega t plus phi minus cos of omega t plus omega t minus phi. We are going to get 1 by 2 Vm Im cos phi minus cos of 2 omega t minus phi. Now, the P, which is nothing but instantaneous power, which equals to 1 by 2 Vm Im cos phi minus half Vm Im cos 2 omega t minus phi. Equation 1. Second term in this equation contains a double frequency term, and it is evident that the magnitude of average value of this term is 0, as the average of sinusoidal quantity of double frequency over a complete cycle is 0. Now, the instantaneous power consists only the first term. So, the power P equals to half Vm Im cos phi, which is the average power in the passive circuit. Now, thus the average power in the passive circuit is given by P average equals to half Vm Im cos phi. We can write this as Vm divided by root 2 Im divided by root 2 cos phi. So P average equals to, this is V I plus cos phi. Let this be equation number 2. In pure resistive network, where phi equals to 0, since the current and voltage are in the same phase, thus the average power in an AC circuit having a pure resistance is given by P average of resistive circuit Vi cos 0, that equals to Vi watts. Let this be equation number 3. For pure capacitive circuit, phi equals to 90 degrees, and for pure inductive circuit, phi equals to minus 90 degrees. As in the capacitive circuit, current I leads voltage V by 90 degrees, and in inductive circuit, current I lags V by 90 degrees, its minus value. P average for capacitive circuit is given by Vi cos 90 degrees, which equals to 0. Similarly, P, that is average power for inductive circuit, is given by Vi cos minus 90 degrees. Cos of minus theta equals to cos theta or cos 90 degrees. So this value is also equals to 0. Thus, the average power consumed by pure inductance or capacitance is equals to 0. Let this be question number 4. In a pure inductive circuit, it can be shown that over a complete cycle, P average equals to 1 by 2 pi 0 to 2 pi V I e omega t, that equals to 1 by 2 pi integral 0 to 2 pi V is nothing but Vm sin omega t, I is nothing but Im sin omega t minus pi by 2 d omega t, as I lags V by pi by 2 in inductive circuit, that equals to 1 by 2 pi integral 0 to 2 pi minus Vm Im divided by, dividing with the 2 and multiplying with the 2, sin omega t cos omega t. That is sin 90 plus omega t is nothing but cos omega t d omega t. Then we can write this 1 by 2 pi integral 0 to 2 pi Vm Im by 2 to sin theta cos theta, which is nothing but sin 2 theta or sin 2 omega t d omega t, minus 1 by 2 pi 0 to 2 pi Vm by root 2 Im by root 2 sin 2 omega t d omega t. So P average equals to minus 1 by 2 pi 0 to 2 pi P I sin 2 omega t d omega t, that equals to minus Vi by 2 pi integral 0 to 2 pi sin 2 t d omega t, can be written as minus Vi by 2 pi. Now integral of sin 2 theta is given by minus cos 2 omega t divided by omega t between the limits 0 and 2 pi by 2. Now substituting these upper and lower limits and solving for this, we are going to get V average equals to minus Vi by 2 pi of 0. It is nothing but 0. Hence average power pure inductive circuit is 0. Similarly for capacitor. Now in case of resistive circuit, P average for resistor is given by 1 by 2 pi integral 0 to 2 pi for complete circuit Vi d omega t equals to 1 by 2 pi integral 0 to 2 pi Vm sin omega t Im sin omega t minus phi is nothing but 0 d omega t. V and I in phase, then phi equals to 0 in this case, that equals to Vm Im by 2 pi integral 0 to 2 pi sin omega t is nothing but sin square omega t d omega t, that equals to Vm Im by 2 pi integral 0 to 2 pi 1 by 2 of 1 minus cos 2 omega t d omega t. Now let us solve this. Vm by root 2 Im by root 2 multiplied by 1 by 2 pi, integrate 1, then you will be getting omega t minus sin 2 omega t divided by 2 in the limits 0 and 2 pi. Then average power in resistive network is given by, so Vi, this value, divided by 2 pi minus 0 minus sin 4 pi by 2 minus sinus 0 by 2, that equals to Vi by 2 pi of 2 pi minus this value is 0 and this value is also as 0. Now we are going to get Vi. Average power for resistive network is given by Vi1. The average power in a AC circuit is also termed as true power or real power, active power. Now obviously in a resistive circuit, Vi equals to IR into I, which equals to IR square R watts, and we can write Vi in terms of V by R, that equals to V square by R. This is also in watts. That is equation number 5. This is regarding instantaneous power or average power of an passive AC circuit.